All right, welcome. Good morning, everybody. So, solving rational equations. I thought I'd give another example to help solve these equations, right? If you don't have the steps, make sure you have these down and pause the video and write them down. I'm going to take them away. So here, when we want to solve this this is a rational equation, right? Why is it rational? Do you guys remember? Remember, rational, what does it mean? It's some a over b, right? You have some sort of fraction going on. And remember, this b cannot be 0. So remember, on the bottom, if I plug in a value for x, like here, x cannot equal -2. Here, x can't be -1. And here, we'll see what x can't be. Okay? So let's follow the steps. Step number 1, factor all polynomial expressions. So here, let's factor the bottom. So here I'll have x over 5 times x plus 1 is equal to 1 over x plus 2 we can't factor, plus 1 over, pause the video and try and factor this. What two numbers when you multiply give you 2, but when you add give you 3, all right? And then it will be x plus 1, x plus 2. Okay, so this was step 1, right? What did we do? We factored the polynomial expression. Now number 2, what are we going to do? We need to multiply through by the common denominator of all the terms. So here, common denominator, right? What will the common denominator be? Here, we have 5x plus 1 and x plus 2. That's what they all have together. The common denominator is 5 times x plus 1 times x plus 2. Okay? We're going to multiply this to every single one of them. Okay? I'm going to pause the video and I'm going to write out what it should be, and you try and do the same. Apply this to this guy, and it will look like this, right? Because I'm taking this, 5 times x plus 1, x plus 2, and I'm multiplying it to this. I'm taking the same thing, I multiply it to this. I take the same thing, and I multiply it to that. So let's see what happens. Here, you have to realize that when you multiply this, this is over 1, right? It's over 1. So what happens here? What is x plus 1 divided by x plus 1? This cancels. Then this cancels. And what are you left with? X plus 2. So then what we write is x times x plus 2 equals, right? We're multiplying this to this. And that's this. Okay, let's look at the next one. This has x plus 2, right? So this cancels and this cancels. So now I have 5 times x plus 1 times 1 on top here, plus, let's look at this. This x plus 1 and x plus 1 cancel. This x plus 2 and x plus 2 cancels. So what am I left with? 5 times 1. Okay, this was all of step 2. Okay, step 3, what are we asked to do for step 3? Reduce whenever possible, and then we're going to solve the resulting equation. So let's take a look. Here, let's step 3 over here. Oh, my bad. Oops, sorry. It's been like a year and I still keep forgetting how to change this camera thingy. Okay, so here, step 3. Right? What I want you to do is, from here, we can solve this. So here, what do? X times x plus 2 is x squared plus 2x equals 5 times x plus 1. So this is just 5x plus 5 plus 5. Okay? 1 second. Let me just hold on. Plus 2x is equal to 5x plus 5 plus 5. So let's just combine the like terms is equal to 5x plus 10. Okay? Now, a lot of you guys are still freezing when we get to this position, okay? You don't have an understanding of what you're doing. If you know what the next move is and why it's the next move, then go on. But right now, I'm gonna write something for you that will give us, like here, how are we going to solve for x? What are you going to do? Okay? Try and pause the video and try and continue forward, and then I'm gonna write something out for you. If the highest exponent in the equation is 2, right? Here, if we look here, our highest exponent is a 2. Then to solve this equation, we want 0 on one side, okay? Why do you want 0 on one side? We'll find out. So let's get 0 on one side over here, right? So here, if I have x squared plus 2x is equal to 5x plus 10, then I'm going to do minus, here, let me do it in a different color. I'm going to do minus 5x minus 10. Minus 5x minus 10, right? And remember, I don't want to do minus x squared on both sides because I want my x squared to be positive. Okay, so always get your ax squared to be positive, right? And if you're freaking out, what's ax squared? Some ax squared plus bx plus c. Okay? Now here, what do we get? We have x squared. Positive 2x minus 5x is minus 3x. Minus 10 equals 0. Okay? And now, why do you want 0 on one side? I don't know how many times I have to say this to you guys. But if you want 0, so we can factor. We want 0 on one side if possible, so if possible, we factor. If it's not possible, we use quadratic formula. Here, are there two numbers when you multiply that give you negative 10, but when you add give you negative 3? Pause the video and try and do it, but it should just be x and x minus 5 plus 2. And now look, once we have this, once you have 0, what move can you use? 0 product property, right? Because you can say x minus 5 equals 0, x plus 2 equals 0. Then plus 5, x equals 5, minus 2, x equals minus 2. Okay? So now here, we solved for x. We did all this work, and we got 2 answers for x, right? Now, going back to this part here, you remember how I said our a over b, our denominator can't be 0. So let's see. Imagine if we were to plug this in, right? Let's look at this denominator. This denominator is 5x plus 5. This denominator is x plus 2. And this denominator is x plus 1 times x plus 2, right? This is the same as this. Now, imagine if x is 5, right? If x is 5, the question is, does x equal 5 make it 0, right? Because if this is 0, then this is 0. And if this is 0, that's not possible. We did that before. Remember, the denominator cannot be 0. If you plug in 5 in here, does it make this 0? If I plug in 5 in here, does it make this 0? Well, let's see. Here, if x equals 5, then what do we get? This is 5 times 5 plus 5. That's 25 plus 5. That's 30. So that's okay. The denominator could be 30. The denominator can be anything but 0. What about this one? This is 5 plus 2. That's okay. We could have 7 for this denominator. And what about here? This is 5 plus 1 times 5 plus 2. That's 6 times 7, and that's 42. And you could have 42 on this denominator, so that's okay. So 5 checks. X equals 5 is okay. But here, what happens when x is negative 2? If x is negative 2, then just by looking at this, which is the one that just shoots out to you right away? It's this one, or even this one, right? You see, look, if x is negative 2, then what is negative 2 plus 2? Then boom, this is 0, and you can't have that. So this is extraneous solution right here. This is extraneous, because we can't have this denominator to be 0. And also, it will make this denominator 0 too, because here, if x is equal to negative 2, what do we have? We have negative 2 plus 1 times negative 2 plus 2. And let's say this is what? Negative 1 times negative 2 plus 2 is 0. And this makes it 0. So now this whole thing becomes 0. Even if I plug in negative 2, watch. If I plug in negative 2 into this, right? X equals negative 2. Same thing. Negative 2 squared plus 3 times negative 2 plus 2. If you solve this out, this becomes what? This is 4 minus 6 plus 2. 4 minus 6, right? 4 minus 6 is negative 2. Negative 2 plus 2 is 0. So it's the same thing. It makes this 0 as well. So this is extraneous. This doesn't work, but this one does. Okay? I hope this helped. See you.